That is very important part in gravitational chapter. We should understand very clearly so that it will be very helpful in a competitive part as well as your NCERT syllabus board also. So what is this satellite? Satellite is a one object which is revolving around the planet in a closed and stable orbit. That is called as a satellite. It is one of the objects. Let us consider this is a one object here. Okay, this is revolving around uniform circular motion. It is revolving around the planet, any planet. Okay, in stable and closed, stable and closed circle. I mean stable and closed orbit. You can say that it is an object which is revolving around the planet in stable and closed orbit. That is called as a satellite. There are three types of satellites out there. What are those three types? One is a natural satellite. Natural satellite it is. Natural satellite. Artificial satellite. Artificial satellite. And the one is a Earth satellite. Earth satellite. So what are these? Satellite we know. What is this satellite? Satellite is a one object which is revolving around the planet in a stable and closed orbit. Right? So that is the satellite. So this will plays a very important role and it is very interesting topic also in gravitational chapter. There are again three types. What are the? Natural satellite, artificial satellite and Earth satellite. What is natural satellite? The satellite which is created by nature. It is a created means it is developed by the nature. For example, you can take it here. Moon. Moon is a satellite. Moon is a natural satellite for the Earth. What is this artificial satellite? Artificial satellite is created by man, or it is on the basis means how the naturally developed satellite is there. Moon, which is revolving around the Earth here. So that is created by nature. So similarly, on the basis of that, we have created one satellite so that it will be useful to study the structure of the planet or how it is revolving, how it is taking the time period. These all things we are going to study. So that is created here, created by man. Who was the invention here? That is artificial satellite. It is created by man. So you can take an example of Aryabhata. So you can take plenty of artificial satellites. There are many satellites are there which is created by man, and they have created in such a way that each satellite will place their own function. It is fixed for that purpose only it is launched. So that is doing its work here. That is artificial satellite. Then the third one is Earth satellite. Earth satellite is what? Which is revolving around the Earth in a closed and stable orbit. You can take many examples here. For example, nothing but the Moon also. Moon is a naturally satellite, but Earth satellite also we can take it as here. The satellite which is only revolving around the Earth. It is mainly for the Earth purpose. So that is again the third satellite. It is which is the object of a satellite which is revolving around the Earth. So next comes here. It is revolving means the satellite is revolving around the planet here with a closed and stable orbit. It has some velocity. That is to do revolving around the planet. It has some energy or it has some speed or a velocity. That is called as orbital velocity here. The velocity which is having the satellite or which will provide the, which will make the satellite to take path, or you can frame here uniform circular motion, or it is revolving around the planet. It has some velocity, it has some speed that is responsible to take a path, or that is responsible to take a revolution here. That is nothing but your orbital velocity, because it is not revolving as if simply, it is taking orbit here. In that orbit only it is going to take a revolution. revolution here. So that is nothing but the orbital velocity. Or else we can say that it is a speed also. So that is speed also. We have studied in a previous class, that is escape velocity. Escape velocity is also tells as a escape speed also. So when it is having that velocity, then it is possible to do that required function there. Similarly, here satellite means what? It is one of the object which is revolving around the planet here in a closed and stable orbit. So it is taking some revolution here, or it is taking a uniform circular path around the planet. So it has some velocity. So that is velocity on which it is, on which path it is showing the revolution. That is orbital velocity. So velocity of the satellite in which it is taking the revolution around the planet, or revolution around the considered planet here. We can take a planet as the Earth also. So revolving around the Earth, revolving around the planet. So that is called as the orbital velocity. Orbital velocity. So we'll find out the orbital velocity. We can note it down here. V naught. V naught means it is an orbital velocity. Consider a satellite. So consider one satellite here whose mass is m here, right? It is taking a uniform circular motion around the Earth. Earth we consider. So this is nothing but the satellite here. I will write it here. Satellite whose mass is m here taken. So this is nothing but the Earth here, right? So this is nothing but the Earth. So it is nothing but the orbit here. Orbit of the satellite. So let me consider this is the Earth here of a radius r whose mass is m here. So it is kept a certain height from the surface of the Earth, right? So what is this? Nothing but the radius of your satellite, right? Now, if you consider a satellite of a mass m here, taking a uniform circular motion around the Earth here, whose mass is m, and r be the radius of the Earth, and h be the certain height. Means we can say that satellite is above the surface of the Earth. So r is what here? This is not the distance between the body and the Earth here. Small r is the radius of the orbit of a satellite. So in which orbit it is taking the revolution on the surface of the Earth. We know that satellite is taking a revolution, or it is taking the circular around the Earth or a planet in a fixed, and I mean to say that stable and closed path it is, or closed orbit. So that's why it is a small r we are considering it is the radius of the arc here. Now once you consider this, now what we are going to check here? Orbital velocity. We know that velocity, it is denoted by V naught here, right? So m is a satellite, we know r is nothing but, we will write here small r is equal to r plus h. This is the radius of the Earth, radius of the orbit here, radius of the orbit, in which orbit satellite is going to take a revolution around the planet here. To do this revolution, see, concentrate here, to do this revolution, the satellite on the surface of the Earth here in a stable and uniform orbit, in a closed and uniform orbit, it needs a centripetal force. You should understand what is this centripetal force. The body which is attracting towards its center. So whatever may be the body which is taking the revolution, or maybe the surface outside the body of it. So it has to be balanced by the body towards its center. So that is centripetal force. The body which is attracting towards the center. So that central force is needed here to do the uniform, stable and uniform motion in a stable and uniform orbit it is. So that centripetal force for this satellite is provided by the gravitational pull of the Earth. So I may clear you all here once again. The satellite whose mass is m here, or else we can say that it is a m, right? Satellite it is. So it is Earth here. But it is not somewhere else. It is in a fixed, stable orbit it is. To do this revolution around the surface of the Earth, right, or around the Earth, it has some force. That is nothing but the centripetal force. The body which is taking the revolution around the planet has to create some force to maintain that centripetal force. If the body is moving in this direction, I mean, if body is there here, it has to take here, it has to complete one path here. To do this completion of one path or a revolution here, that force should be developed. So that is nothing but the central force. The body should be balanced. Satellite should be balanced with the planet force. That is centripetal force. That required centripetal force to make a revolution around the planet is provided again by the planet which you have considered, or else which you have considered here, Earth. That is gravitational pull. So centripetal force is what here? Centripetal force is the required force. Centripetal force is the required force to maintain or to do the revolution around the Earth. Right? So mv naught, right? Centripetal force. Centripetal force is what? It is responsible. So mv naught square by r. So this centripetal force is responsible, or it is one force which made the satellite to take a revolution around the Earth here or a planet. Right? To balance this force, where you will get the balancing force? Simply it is not revolving. It has to be balanced. Means the force which has to be balanced by center of the planet. That is provided when the gravitational force is acting on the satellite by the Earth. So that is nothing but the gravitational force. Centripetal force is provided. The required centripetal force for the satellite to take a revolution around the planet, it is provided by the gravitational force acting on a satellite by the Earth or by the planet here. What is the gravitational force here? F is equal to G capital M small m by r square here. Right? Now, centripetal force is equal to the gravitational force, or else we can say that centripetal force is required centripetal force is provided by the gravitational force which is acting on satellite by the Earth. Now what is here? mv naught square by r here. So that is gm capital N small m by r square here. Now look at here. R will get cancels. mv naught square is equal to gm small m by r unit. So v naught square is equal to, so here m also will same also will get cancelled here. It will remain with the gm by r. So v naught is equal to, square is then root of gm by r. So this expression will tell the orbital velocity of the satellite. Orbital velocity. So orbital velocity of the satellite here. So what is this satellite? You know, that is one of the objects which is revolving around the planet in a stable and closed uniform motion, right? Closed orbit, maintaining the uniform motion around the planet here. To do that revolution, it needs some velocity, right? That is called as the orbital velocity. The velocity which is taking place, or a revolution taking place by the satellite around the planet, it is called as orbital velocity, right? How it is? The satellite will be from above the surface of the Earth. So that is taking around the planet here. Planet we have considered Earth here. So it needs some centripetal force. The required centripetal force. We are doing some work, means we need a energy or we need a force. So if we have that quality, then only we can be able to do some function. Similarly, if satellite is doing the revolution around the planet here, it needs some force. That is nothing but the centripetal force. So centripetal force means what? The force which is attracted towards its center. So here Earth has a quality of the body which is attracting towards, or it has a capacity to attract towards its center. So similarly, the required centripetal force for the satellite to take a revolution around the planet, it is provided by gravitational force which is acting on the satellite here by the Earth. So centripetal force will be equal to gravitational force, right? So mv0 square by r is equal to gm by m is the mass of the Earth, m is the mass of the satellite we have considered, which is a certain height above from the surface of the Earth. So to do the revolution around the Earth here. So mv0 square is equal to gm m by r. So v0 square is equal to gm by r. So here square is there. I will take out it is in the form of root of gm by r here. So that is, this expression will give the orbital velocity of the satellite here. So once you know what is satellite, what are the types of satellites, right? Then to do that satellite function, so it will give a plenty of usefuls for us. So it will give the surface of the Earth. We will study how the planet will be there, how it will be going on the process there. So what will be the surface of the planet, how the planet will be there, many things it will be useful to understand about that planet. So that is because of satellite here. So that is, next we will study here how the launching of satellite will be takes place. So orbital velocity is independent of the mass of it. So this orbital velocity is there. No, just now we have calculated v0 is equal to root gm by r. So r is nothing but here radius of the orbit of a satellite in which it is taking revolution around the planet. Now I am using here planet. In place of planet we are using here Earth, because any object which is taking revolution around the planet means it is a satellite. Here we are considering most probably planet as a Earth here. So now onwards I will speak, or I will consider it as a planet as Earth here. So you need to understand better. So orbital velocity of the satellite, it is totally independent of the mass of satellite here. It is dependent on the mass of the Earth, right? And acceleration due to gravity of the Earth here. That is very, very important. So once it has acceleration due to gravity, means how much required centripetal force is possible, means how much it is required to take a revolution around the planet. So that force should be provided by the gravitational pull or gravitational force which is acting on the satellite. Then it is able to do the revolution on stable and closed orbit in a uniform motion. So that is very important here. So that's why it is orbital velocity. It's not dependent upon its mass, whether it is heavy compared to Earth, whether it is less compared to the Earth. So it is totally independent. So it is only dependent upon the mass of the Earth, orbital velocity, right? It is only dependent upon the mass of the Earth and acceleration due to gravity of the Earth. Now, if you consider r here, so what is this r? The orbital velocity. Just now we said. Now, acceleration due to gravity on the surface of the Earth. How much it is? G is equal to gm by r square. Sorry, capital R square is there. Now, I said no, orbital velocity totally independent of mass of the satellite, dependent on mass of the Earth and acceleration due to gravity. Acceleration due to gravity on the surface of the Earth. So on the surface of the Earth, acceleration due to gravity is how much? G is equal to gm by r square. Now what it is, I can write it here, gr square is equal to gm. Now put the value of gm in the orbital velocity. What you will get? u0 is equal to root of gr square by r is there here. this is nothing but the radius of the orbit here. Now place here r plus h, right? Now what you will get? So what you will get here? R g r square divided by r plus h. Now look at here. This h is what? Above the surface of the earth. If the satellite is moving very close to the earth or moving very nearer to the earth, so h will be lesser and lesser than r. Means it's almost compared to the radius of the earth. Concentrate. If the satellite is moving very nearer to the earth compared to the radius of the earth, height will be neglected here. Height will be neglected because it is compared to the radius of the earth. It is very nearer to the earth, so it is neglected. Then what will remain here? G r square divided by r. So this is neglected. When it is neglected? When satellite is very nearer to the surface of the earth as compared to the radius of the earth. Radius of the earth is this much. As it is very nearer to the earth, the height will be lesser or lesser than r it is. It's smaller or smaller. It's almost as a radius of the earth only. Now at that time height will be neglected. Means which is a certain height above from the surface of the earth, it is almost neglected because the revolution taken by the satellite on the surface of the earth, it's almost nearer to the radius of the earth here. So height will be neglected. Then what is remained here? G r square by r. So this will get cancelled, remains with g r here. So orbital velocity when it will be in this form. This is very important. So when orbital velocity has a certain height here, in place of r, you can write it here gm by r plus h also. So gm by r plus h. What is this? This is nothing but the radius of the orbit in which the satellite is taking the revolution around the earth here. Now gm by r plus h. When this h will be neglected? When the satellite is moving very nearer to the surface of the earth. Right? While taking the revolution, it is moving very nearer to the earth's surface compared to the radius of the earth. At that time, h will be neglected. Very less it is. Just now I said no. H is very less than compared to radius of the earth. At that time, h will be taken out from the orbital velocity formed here. Then what is remain here? Root of g r here. So once you consider here, so you know very well acceleration due to gravity on the surface of the earth. If you consider 10 meter per second square, right? If r is nothing but the radius of the earth, 6,000 kilometer per second, then what you will get? 6.4 into 10 to the power 6. Put the value here. V naught is equal to 10 into 6.4 into 10 to the power 6 here. So what you will get here? 8 kilometer per second. You do it. So you will get 8 kilometer per second. So this is the orbital velocity of the satellite revolving close to the earth's surface. So this is what? Orbital velocity of the satellite. Very close to the earth it is. So orbital velocity of a satellite close to the earth. So we need to understand here, close to the earth. So why I am explaining this part and this part means, as a part of your NCERT syllabus, they may ask this expression, how the expression about the orbital velocity, or derive the expression of orbital velocity of the satellite. So you may get for 5 marks or 4 marks. But as you know, this expression is how it is a frame form. V naught is equal to root of gm by r, rho naught is equal to root gr. So once you know this one, you can directly apply this formula for your competitive questions. So they will find what is the orbital velocity of that given satellite which is taking the revolution around the planet. So this is a shortcut. We have used this part means in very short intervals of time we will solve the plenty of competitive questions, or we get the, in that given 4 options, we can directly find out which is the expected answer in that question, right? Escape velocity, then we can find out the relation between the escape velocity and the orbital velocity. So what is this escape velocity here? The velocity which is escape from the gravitational pull of the earth. So what is that? Root of 2gr. Those who did not understand this one, you can go for the previous class there, and then you got the clarification, then come to the find out the relation between the escape velocity and the orbital velocity. So what is this? Orbital velocity 2gr. So ve by v naught. What we will get here? 2gr by gr here. So escape velocity is equal to root 2. Escape velocity is equal to root 2 v naught. This is also very important relation between the escape velocity and the orbital velocity here. Velocity and the orbital velocity, as I mentioned here, this is not there for your NCERT syllabus. I need to say that relation between the escape velocity and orbital velocity, but it is very important to understand as part of your competitive here. Once you know this directly, this one, how it is related to each other, then I will explain here. So once you know this one, you should remember this. Escape velocity is equal to root 2 of orbital velocity. Once you know this, if they are asked, then directly you can apply the formula of it and find out the solution. So next part we will solve, the next part of it will just note down how the satellite will be launching of satellite. So to launch the satellite, there are 2 velocities. I mean to say that we need to provide 2 velocities for the satellite. So as if we want to launch the satellite, we will launch the satellite. It is not like that. We need to provide the 2 velocities for the satellite. What is that? One is a vertical velocity, another one is a horizontal velocity. Vertical velocity, we need to supply 2 velocities here. Vertical velocity. Another one is a horizontal velocity. Right? So vertical velocity and the horizontal velocity. So what is these velocity? These are nothing but the orbital velocity of the satellite. Right? So what is that orbital velocity? The velocity which the satellites are able to do the revolution around the planet. Right? Why we need to supply the 2 velocities here? Vertical velocity which will bring the satellite into a certain height from the surface of the earth. Right? So let us consider here this is the planet. This is the satellite here. Right? So it will be vertical velocity will bring the satellite. Vertical velocity will bring the satellite from the surface of the earth, certain height. I mean to say that required height. Vertical velocity will bring the satellite for required height and get detached. Means it will take to the certain, it will take to the required height to get ready for the revolution, to take the revolution around the earth. This is very important. When you supply the vertical velocity to that satellite, it will go to the required height where it has to reach. It is get ready to take a revolution. Then horizontal velocity, what it will do once it is reached to the certain height, right, by the vertical velocity, right, by the vertical velocity. Now it has to take a revolution. It is ready to take a revolution. Get ready position it is. Now once it is taken, it will go to the horizontal velocity. We need to supply the horizontal velocity, then it will start moving towards the revolution. It will go for the revolution. So these are very important to launch the satellite here. Not suddenly if you give the velocity, it will start taking the revolution. It has to get away from, means certain height, it will move. It has to move to take a revolution around the planet or the earth here. That is possible only when vertical velocity is there for that satellite. Once it is reached to the certain height, fixed, I mean it is get ready to that taking the revolution. That is possible only with the horizontal velocity here. Now to launch this satellite, we understood two velocity we have to provide for that satellite to take a revolution around the earth here. Now to this we are taking the help of two-stage rocket. What is the two-stage rocket here? In first stage, again the vertical velocity will be taken. So two-stage rocket. Two-stage rocket we are considering here. To launch the satellite, we are making use of two-stage rocket. In first stage, what will be there? In first stage, right, the rocket will take the whole system for the required height and it will turn into 90 degrees. Now look at here. So, if this is the satellite, consider it will be in the form of rocket here. Right, it will be in the form of rocket. So, first what it will do in first stage, so it will move towards the desired height and it will turn into the 90 degree. So this is nothing but like this only. So it will be in the form of 90 degree, turn into 90 degree. Rocket will take whole system into the required height and get turned into the 90 degree. First it will be somewhere else, angle will be different. So once we supply the vertical velocity to that, so what it will do? The rocket will take whole system, whatever may be the inside it is, satellite and required things, all the things, it will take it to the some desired height. It should be get ready to go for the revolution. So that space it will reach and turn into 90 degree, exactly 90 degree with the surface of the earth. Then second stage, what it will do? In second stage, the whole rocket, whatever it is, it will reach to the certain height. No. So what it will do? It will turn into horizontal direction. This in second stage, the rocket, that system will be there. No, it will be turned into horizontal direction to do the revolution. So what it will do here? Once in first stage of rocket, the rocket will take the whole system and get into the required height there and it will get detached. Other things will be get detached, only satellite will be coming to that position. What is that? Exactly 90 degree, turn into 90 degree here. Then after in second stage, we need to supply the horizontal velocity there. When it will be gain the horizontal velocity, it will turn into horizontal direction and get detached. Satellite will start taking the revolution around the earth. So this is very important. So to launch the satellite, we are using the two-stage rocket here. In first stage, the whole rocket, the rocket will take whole system into the desired height and turn into 90 degree, exactly 90 degree with the surface of the earth. Then once horizontal velocity is gained by the satellite, here it will be, once it is raised to the 90 degree, the other things will be get detached. And once it is gained the horizontal velocity, it will start moving in the horizontal direction and get detached the remaining things. The satellite will start rotating around the planet. This is the uses of the rocket for launching the satellite. Now next, how the path will be processed by the satellite once it is launched with the help of two-stage rocket. Let us understand how the path will be followed by the satellite once it is launched. Now let us consider here planet, right? So it will be in the desired height here, right, from the surface of the earth. Once it is reached to the earth here, right? Let me consider here, I will write it here, earth. Now once satellite is launched by the help of two-stage rocket, just now we have understood here. So it will get the horizontal velocity. So it will just move in this direction. horizontal velocity gained by the satellite. So motion of the satellite is depending on the velocity given to it. So how much velocity we are giving to that satellite, that much velocity only it will start moving or takes place the motion here, right? So once horizontal velocity is less than orbital velocity, it will take the parabolic path. So that is nothing but the first part. I will write it here, first part, right? First part. And it will start moving and fall into the earth. Once the orbital velocity, right, it reaches to the second part. When it is orbital velocity is slightly less than the orbital velocity. Here it is completely less. Here it is slightly less. Then what it will happen? Slightly less than orbital velocity. Right? That is spiral path means spiral path. So again it will move towards, right? It will start rotating and it will not complete, it will fall down. Once again the horizontal velocity. So horizontal velocity, when horizontal velocity is equal to the orbital velocity. So which path it will follow here? Let me consider here a path 3. That is nothing but the stable, closed, uniform motion it will take. Means it will be stable and closed path it is. Uniform motion it is. Right? That is the path 3. Circular motion it is. It is not a elliptical or it is not a parabolic. First path is when the horizontal velocity of the satellite less than orbital velocity, it will take the parabolic path. Second path, look at here, if horizontal velocity of the satellite slightly less than the orbital velocity, it will go for the spiral path. And these two paths, first part and second part, parabolic path, spiral path, start moving and fall onto the earth only. It will not complete the revolution. Then third part means horizontal velocity of the satellite reaches or equal to the orbital velocity, it will start rotating in such a way that it will complete the revolution in circular motion. And once again horizontal velocity. So when horizontal velocity, okay, greater than orbital velocity or less than escape velocity. You need to understand here. Once horizontal velocity greater than orbital velocity and less than escape velocity, it will take the path of ellipse here. It will take the path of ellipse. As Earth as one of the center of foci of ellipse. For this path, ellipse path, Earth will place the center here, one of the foci of center of ellipse here, right? So this is the elliptical path. And once the become one of the foci of the ellipse, once it is horizontal velocity is greater than escape velocity. Once horizontal velocity is greater than escape velocity, then what it will do? It will move away from the gravitational pull of the earth, right? So let me explain once again here. Once launching of satellite with the help of two stages of rocket here. First stage, what it will do? Rocket will take the entire system and get to the desired height where it is ready to take the revolution around the earth and turn into 90 degree exactly, right? Once first stage is reached, the second stage horizontal velocity will place the role here and it will move towards the horizontal direction and start rotating around the planet. Now how the path will followed by the satellite here? Once the satellite reach to the certain height or a desired height to take the revolution around the earth, it will take the first path 1 year. What is the first path here? Horizontal velocity of the satellite is less than orbital velocity. It will go for the parabolic path, right? So it will go for the parabolic path and it will takes and falls on the earth. Similarly, horizontal velocity of the satellite will take the second path that is also takes and falls on the earth. That path is what? Spiral path. That is a slightly just less than the orbital velocity. Slightly less than the orbital velocity. And when the horizontal velocity of the satellite is equal to the orbital satellite here, third path. So what is the third path? It will take the circular path, uniform circular motion, stable and stable and uniform circular orbit. Uniform circular motion takes place on the around the planet here. That is, once horizontal velocity of the planet is equal to the orbital velocity. Then, when horizontal velocity of the satellite reaches or it will becomes greater than the orbital velocity and less than the escape velocity, it will take the fourth path. That is, fourth path is nothing but the ellipse path. It is that will place the ellipse path, not in a circular motion, not in a closed and stable uniform motion. It is in the form of ellipse, just like a ellipse egg, right? So where the earth will place the role of one of the foci of ellipse. It is one of the foci of ellipse. Once the orbital velocity, horizontal velocity of the satellite greater than the escape velocity, it will take the horizontal path and escape from the gravitational pull of the earth. It will not show any path which is assumed to be as a revolving around the earth. So we need to be conscious about that, how much velocity we have to supply to the satellite so that it has to take a revolution around the earth. That is nothing but the launching of satellite. So very important here. So for the launching of satellite, we are using two stages of rocket. First stage it will go to the desired height and second stage it will go to the horizontal direction, and path it is depending upon the path followed by the satellite. It is totally depending upon the how much velocity is given to that satellite, right? Spiral path fails here. Again the parabolic path fails, and stable and closed uniform motion fails here, means it is in a circular motion here, right? Once it is equal to the orbital velocity, right? It is depends in which purpose we are launching the satellite, depends here. So but these two are falls on the earth only when it is less than the orbital velocity, very less than the orbital velocity. Once it is equal to orbital velocity, then only it is possible to get the revolution around the earth. Maybe the path is uniform circular motion or the ellipse. To perform the elliptical path, we need to supply the horizontal velocity to the satellite greater than the orbital velocity, but we should be very conscious about that. It should not greater than the escape velocity. Then that case is also there. Once the horizontal velocity of the satellite is greater than the escape velocity, it will never take the path. It will not follow the path around the planet. It will escape from the gravitational pull of the earth, right? So this is about the launching of satellite, how the process is going on, how the path is followed by the satellite. In next topic